Okay, year 11, this screencast is on the inverse function. We've been looking at functions and what defines a function and things like that. Now we're going to look at inverse functions and what they're all about. So let's just start by getting the notation right. The inverse function of f of x, and it's written f minus 1x. So we'll get that out there at the start because the notation is important. This f minus 1x, that says the inverse function of x. It doesn't mean 1 over f of x, it means the inverse function of f of x, and we'll now go on to define what the inverse function of f of x actually means. Okay, so there's a few ways of looking at this, but in its simplest form, the way I like to talk about it is that if you've got a function, f of x, what that function will have, it will have a whole set of coordinates, a whole set of ordered pairs. We talked about that's actually what a relation is. A function is a relation that is also that has that property that passes the vertical line test. So if you think of all those ordered pairs, then the inverse function is a switch, an xy switch of all those ordered pairs. Someone's gone along and changed all those ordered pairs around to read in a different order. So some practical joker has come up with this idea, I feel, and it's the inverse function is a result of a coordinate switch. So let's have a look at an example. The inverse function is written. Okay, the inverse. Right. So the inverse of a function is found by affecting an xy coordinate exchange. So what that means is, for, let's say, the function 2x plus 3, let's take some coordinates. Let's just take a whole bunch of coordinates here. Let's go for the function f of x equals 2x plus 3, some ordered pairs are. Let's go. So let's go with minus 1. You put minus 1 in there, you've got minus 1, 1. That's one of them. Put 0 in there, you've got 3. Put 1 in there and you've got 5. Put in 100 and you've got 203. Put in minus 20 and you've got minus 37. You get the idea. We could do this for a long time. Now what happens to those and all the other ordered pairs is that they're going to switch around. So therefore I'm going to go having the therefore f minus 1x, the inverse function of x, will have ordered pairs of, and now let's go through it. It's going to have ordered pairs of, well, let's do a switch, 1 minus 1, 3, 0. All these ordered pairs are changing themselves around. 203, 100. Minus 37, 20. It's the practical joker. He's just gone and switched them all around while they were asleep, while they weren't watching. So look at that. So the original function, 2x plus 3, which had those ordered pairs, now has these ordered pairs. So that's the effect of having the inverse function. Okay, so what does that look like graphically? Well, let's have a little look. I'll do my best to get this sketch out. So the original function minus 1 1. So I'm just going to get an idea here. 0 3. So it's got this sort of thing going on. 1 5. It's a straight line. Gradient 2 is doing this. If we kept on going 100, 203, we would go. But right, we're going to just draw the line through there. So that's the original function. That's f of x. Now let's give another colour out for the inverse function. It's got 1 minus 1, 1. So basically this point here went from minus 1 to 1 minus 1, so it's gone down there. This 0, 3 has become 3 naught, so that's gone to there. This one here, 5 1, has gone up here. And you can see what's going. This one's flatter. This one's got a gradient of 1/2, and it's going through like this. I'm going to try and draw it like a bit like that. So that's if you get 203 100 be out there somewhere, minus 3 720. This is f. This is the inverse function of x in black. Now what you see there is those graphs, the black and the red have just got the opposite coordinates. And if you think about that for a second, what that is the same as doing is it's reflecting in the line y equals x. So graphically, the inverse function of x is a reflection in the line y equals x. Now it makes sense if you think about it, because there's been an xy switch, remember. Okay, so all these points are reflected across there. You can see if we just look at a couple, this point here has gone to this point here, so that's being reflected through that line there. 3 naught went to naught 3, so you can see if you join those points up, what you've got is they're the same length there, so they make right angles there. This point here, so these are all perpendicular. You see they're mirror images. This point here, which is where the coordinates are the same. So if we do a coordinate switch, the coordinates are the same. You don't see any difference here. So there's the point that they will intersect at the point where the coordinates are the same. So alright, what did we start with? We started with what is the original function? Y equals 2. Function of x equals 2x plus 3. Okay, so that's how you do it graphically. Algebraically, let's have a look at algebraically. Finding f minus 1x, the inverse function, from the inverse function. So from the original function. Right, so step one, write the f of x notation as y equals. So we're going to write it as, so step 1 is f of x is 2x plus 3. We're going to write it as y equals 2x plus 3. Okay, now second step is make y the subject. Sorry, back one. We've got to do the xy switch. XY switch. Okay, so we'll do that now. So the y becomes x and the x becomes y. That's easy enough. Step 3, make y the subject. Okay, so make y the subject now. So 2y is equal to, what's this, x minus 3, so y is equal to x minus 3 over 2. And the last thing to do, so we've got our inverse function now, use f minus 1x notation. So we just rewrite that y now as f minus 1x equals x minus 3 on 2. So the original function is there, and the inverse function is there. Now, I'll just get rid of those. So we've got, we've now looked at how to find the what it means. The inverse function is a coordinate switch. Graphically, reflection y equals x. Algebraically, the 4-step process. And just simply to finish here, let's just have a look at what this function of x, 2x plus 3, what happened to the x? What look at the operations on 2x plus 3. So how do we get 2x plus 3? Well, firstly, we started with x, it was multiplied by 2, and then 3 was added. That's how we got 2x plus 3. The result of multiplying x by 2 and then adding 3 gave us 2x plus 3. Now if we go in the opposite order and do the opposite, we would subtract 3 first and then we'd divide by 2. That would be the opposite. So if you start down here with x and you subtract 3 and divide by 2, then our inverse function looks like that. So that there is our inverse function of x going up that way, and this is our function of x. So 2 or 3 different ways there. We've had a look at what the inverse function means, and this is quite nice. It's the opposite operations in the opposite direction. It all makes perfect sense, and inverse functions are fantastic like that. It's quite a logical process. Okay, I'm going to leave it there. It's an 11-minute video, and I'm sure you've heard enough from me, so I'll see you in class tomorrow.